Hello everyone, in this video I'm going to discuss the example for differentiation by using the first principle. Kindly refers to the question. By using the first principle, we have the formula given. Find the first derivative of the function fx, which is equals to square root of x plus 4. So kindly substitute the situation. Limit when h approaching 0 for the function, we have the square root. So x plus with the h plus with the 4 minus, we have the square root x plus with the 4 over the h. So if we substitute the value 0 into the function, very obvious, we will have indeterminate form, which is the IDF. So my strategy for this question would be multiply by the conjugate. So do remember, only expand from one part and then make use of the formula a squared minus b squared. So meaning that, let's say this is the a squared, this is the b squared after we expand. So rewrite the situation. Limit h approaching 0. So we have x plus with the h plus with the 4 minus, we have the x minus the 4 over, we have the h multiplied with the square root of x plus h plus with the 4 plus, we have the square root x plus with the 4. So can we simplify? So limit when h approaching 0. So we can see in here we have the h over, we have the h multiplied with the square root x plus with the h plus with the 4 plus square root x plus with the 4. So limit when h approaching 0, we have 1 over square root of x plus with the h plus with the 4 plus with the square root of x plus with the 4. So if we substitute the 0, so very obvious, we have 1 over square root x plus with the 4 plus square root x plus with the 4. So the f prime x is equals to 1 over 2 multiplied with the square root x plus with the 4. So that is the first derivative. In this video, I'm going to discuss the example for parametric differentiation. Given a parametric equation of the curve as the situation given, we have the x, which is equals to t squared minus 3t cubed. And then we have the y, which is equals to negative t squared, and then multiply with 1 over 6. Find the dy dx. So dx dt equals to 2t minus 9t squared. dy dt equals to negative 2t over the 6. Rewrite the situation. We have the negative t over 3. Next, we have the dy dx, which is equals to dy dt multiplied with the dt dx. So here we have negative t over 3. Multiply. Do remember to flip the situation. So where we have 1 over, we have the 2t minus the 9t squared. So if it refers to the situation, we have the negative t over the 3. Multiply, we have 1 over, factor out the t, so we have 2 minus 9t. So rewrite the situation. We have the dy dx, which is negative 1 over 3, bracket, we have the 2 minus the 9t, bracket, power negative 1. So that is the first derivative. Continue. For the second derivative, we have the formula. Differentiate the dy dx with respect to t. Multiply with the dt dx. So differentiate the dy dx. First we have negative 1 over 3, bracket, negative, bracket, 2 minus 9t to the power negative 2. Differentiate the internal function and we have the negative 9. Multiply, we have the dx dt become dt dx. So where we have 1 over, we have the t, bracket, 2 minus 9t. So rewrite the situation. So in here we still have the negative 3 over, we have 2 minus 9t, bracket, to the power of 2. Multiply, we have 1 over t, bracket, 2 minus 9t. So for the second derivative, we have the situation, negative 3 over the t, multiply with 2 minus 9t to the power of 3. So that is the first and the second derivative. Next we have the situation, hence, evaluate the dy dx at the point we have, for the situation, x is equals to 0 and the y is equals to negative 1 over 54. So if we substitute into the situation in here, we have 0, which is equals to Factor out the t squared. So here we have 1 minus 3t. So t squared equals to 0, meaning that t equals to 0. Then we have 1 minus 3t equals to 0. So t is equals to 1 over 3. So that is the value of t when x equals to 0. Next, we have to test for the situation y is equals to negative 1 over 54. Negative t squared over 6 equals to negative 1 over 54. So rewrite the situation. So we have the t squared, which is equals to, we have the 6 over 54, t squared, which is equals to 1 over 9. So the 9t squared minus the 1 equals to 0. So we have the 3t minus 1. And then we have the 3t plus it to 1 equals to 0. So the value of t will be equals to negative 1 over 3. T equals to 1 over 3. So we have to check the situation when x equals to 0 and the y is equals to negative 1 over 54. And we notice that we have the common terms where we have t equals to 1 over 3. So meaning that valid when t equals to 1 over 3. So kindly substitute the value into the first derivative in here. So the dy dx is equals to negative 1 over the 3 multiplied with 2 minus the 9 over the 3. So if we substitute 1 over 3 bracket, we have the 2 minus the 3. So where we have the negative 1, then we have 1 over 3 for the dy dx when the t is equals to 1 over 3.
If you are new here, kindly consider subscribing to this channel and share this video to your friend. Thank you so much for watching this video. Bye.